Hey guys, these are your notes for lesson 1.1. If you're watching this, it's either because we didn't get to it in class or you weren't here in class or for whatever reason, just going to get through a couple of the vocab so we don't have as much to do in class. It just starts with the definition of the word statistics. It's the science and art of collecting, analyzing, and drawing conclusions from data. So that first blank is supposed to be data, which is the first thing we did in class. I asked you to fill out this little questionnaire. We compiled the class data. We're not going to go back through that. We will use that data throughout the school year, but for now, we're just going to jump down to that next blank, which is a variable. We've had variable in algebra class. You know it's a thing that can take on any value like x or whatever. But when we talk about in statistics, we're specifically talking about a characteristic, a number or quantity that can be measured or counted. So hair color would be considered a variable because it varies from person to person. You could also have height as a variable or age as a variable. And then we get into categorizing them further on the next page. Variables can be categorical or they can be quantitative. Another way to think of the categorical is qualitative, which I'm hoping is a term you've heard before. The first blank is for that categorical, for the qualitative. So it assigns labels. Variable assigns labels that place each individual into a particular group. So when I was saying that a variable could be hair color earlier, that would be a categorical value. Or something could be like somebody's zip code. Since it's not measuring anyone, but just putting them in a group, like this zip code is for the people who live in Godfrey. This zip code is for the people who live in Alton. It's just putting people into categories. Whereas quantitative variables are for measurements. Quantitative. Every quantitative variable will be a number, but not all numbers are going to be quantitative, like the zip code example. So these will be quantities, they will be counts, they will be measurements. So for example, somebody's age or the number of pets somebody has. If it's counting or measuring something, then it's quantitative. No matter which type of variable you have, they may be discrete or they may, well, I guess that's not true. For quantitative variables, they may be discrete or they may be continuous. Discrete variables can only take on integer values. Integers being a math way of saying essentially whole numbers. They could be negative also, but we're not getting into that. But whole numbers. So something that would be whole numbers would be the number of languages you speak. Because you can't exactly speak 1 2/5 of a language. It has to be I either speak one language or I speak two languages. Continuous, however, can take on literally any value. So for my example for that, I'm going to put height. Because I don't have to just be 5 foot or 5'1". I could be like 5.0002 inches tall, not inches, feet tall, or 5.00003 feet tall. It's a continuous variable because it can take on any of those values. Some of these studies we're going to look at and deal with could be univariate or they could be bivariate, those prefixes being the important part. When a study looks at one variable, the prefix for that would be the uni or the un, we're going to say that we are looking at univariate data. So if I just collect data on, cell phone use, that's univariate. Cell phone, that's not the letter U, I have an eraser. Cell phone use. However, when we conduct a study that examines the relationship between two variables, we are working with bivariate data. Bi meaning two. So I could still consider the variable of cell phone use, but maybe I'm also comparing it not just to the variable of cell phone use, but it could also be cell phone use and age. There might be some relationship between cell phone use and age, so I can look at it that way. Once you get all these variables categorized and determine what you're looking at specifically, then we are looking at something called a distribution. A distribution of a variable tells us what value the variable takes and how often it takes those values. Oftentimes, it's a fancy way to say a chart. We will graph these charts, sometimes as a bar graph, but it's to answer questions like, how would you describe the distribution of the age of your oldest parent from that data collection? I want to know what is important to notice. How do you describe them? So when we look at these graphs and summaries, there's lots of different ways to do it. The first one that we're going to do is a dot plot. And then it gives the steps for going through and doing that. If we didn't get to this in class, we're going to do it in class the next day, so you don't need to worry about getting through example 1, because we really need to get good at dot plots. They show up on the AP test. It is an important thing, and it's honestly not that complicated. So hopefully we'll be able to get to that pretty easily, and then we'll look at what the characteristics are that are important from there. But for now, that should be good enough.